Boom. Alright guys, welcome back to the Craft Tech channel, and today I'll be showing you guys how to create this audio visualizer, wonderful beat that I created myself. Yeah, can you see the way it's bouncing? I can also change the way it displays here by changing this so I can do, can you see the way it displays? Yo, come on. Yeah, I actually created this beat myself, so you can follow this link here to vibe along. Yeah. Alright guys, let's get started. So let me show you how I did that. Alright, cool. So I have this basic setup here. I have this UI here with this know your crafts. Let me zoom this in so you can see. So I have this, basically it's an H2 tag, okay, containing this know your crafts UI with this family, this font family, Vedena, Geneva, Tahoma, Sans Serif. The font size was XS large, color green, yellow. They have this basic UI here. Then for the text AI audio mixer, I have that in my H1 tag right here. And also for the file input, how we access the file, we access the file using this input API here with the type file ID as audio file. I think we got that here. Okay, I haven't got that yet. So we have it accepting only audio files, okay. Yeah, and then our visualizer, where we have our display, our graphics, is this canvas here. I think we've gotten that already, which is this visualizer. Yeah, we've gotten that already. So that's our basic setup. So let's get started with JavaScript. So for the JavaScript, I've actually gotten all these tags that we have here. This document object module, the H1, everything that is here, I've gotten here. So now what I have to do first of all is by getting the audio file, which is this stuff that is here. This here, right here. So you have to get element by ID or using query selector. So we are going to say const. Oh yeah, I can copy this and paste it. I'll call this audio file. Okay, and I think the name of the ID was audio file itself also. So we're going to use audio file right here. Okay, now for this audio file, we're going to add an event listener saying audio file dot add event listener. And the event listener, when we change the file, we want to access the file that we had inside. Okay, when we access the file, we're going to pass this event. Okay, we have this right here. Okay, very good. Now this E actually means events, the events that that belongs to this audio file. Okay, everything has to do with it, with the event listener. Okay, now very good. So now what we'll do next is to access the file that we just inputted. So we have constant file equals to e.target, okay, dot file. Now this file I will show you in the console tab. Okay, that's what we have here. So we have this already running here. So we have definitely, I'm going to say console.log the file. So this only happens when I click. Remember, the event listener is change. So when I change whatever is there now is empty. So when I change it, let's see what happens. So choose file. Let's choose this. Okay, cannot read property of reading 0. Okay, I think there's a problem here. Let's see. Get the ID audio file. We have this. We have the file. Oh, sorry, it's meant to be files. So let's refresh. Let me pick the file again. Pick this. Yeah, automatically. Now you can see here we have the properties of the file, the name, KUC bits, synergy. We have the last date modified. We have a lot of information about this file here automatically. So now what we do here is, after getting this file, we're going to create a function that checks if the file actually exists. I'm going to say check file. Which file? I'm checking this file. So I'll pass it as this into the function automatically. I have this. So we'll call this check file. So check file up with this. Okay, I'm going to check this file in this. So what this function is actually doing is to make sure that we have this file if it is actually available in our in the file manager. Okay, so we're going to say if that file actually exists. If that file exists, do this, but else if it doesn't exist, do this. We can also do this if else statement using the ternary function, but today I'm going to use the if else itself. Note ternary function, it's what we call ternary operator, sorry. So automatically here I'm going to say if it exists, yes, then we can now analyze the file. That's another function I'm going to create. I'm going to say analyze and play. I'm going to analyze and play the file, which is that file that we passed there. Okay, that's nice. Then yeah, when I analyze the file, but if it doesn't exist, we're going to say alert. Let's say an error occurred. yeah, an error occurred. So now let's create this file, this function here. The next here is now create that function of analyze and play. So let's analyze and play the same file that we passed inside there. So now for us to analyze and play this stuff, we have to okay, when we get the file, okay, first of all we check if the file exists. Yes, now when a file exists, we're now going to analyze the file and play the file. So now we don't have any audio API that we can use to play automatically, so we can create that in JavaScript, saying constant audio equals to new audio. Can you see what I have here? I have this new audio. Now for this new audio, actually it needs a source, an src file. Src is just like your image tag. You have your source, you have the source which contains where the file is actually coming from automatically. So here the same thing too. I need the source for this audio that we just created here, this audio API that we created here. Now for this audio that we created here, we need a URL. So now for that URL, I'm going to say this file that we have here, I'm going to create a URL from that file and attach it into this audio file. So I'm going to say that the audio URL should be equal to, okay, there's a method called URL to create object URL. Yeah, so we are going to pass that file into it. Yeah, so automatically if we console.log that audio URL, you're going to see that now. Inspect. Okay, this is our console. Then if I choose a file, choose this, and I open, can you see we have this already? We have this URL here. If I click on this, can you see? You cannot get it here for now, but we have this URL automatically, this source file for that audio file automatically. So I can delete this for now. When I pass it into this audio URL, you're going to see it's going to appear as a source for that. So let's console.log the audio that we have. Let's see what it gives us. So let's choose a file. We'll choose that, open it. Okay, it said cannot get that. Let's refresh. Oh, sorry, there's an error. Yeah, because we did not use, it's meant to be audio URL, so not audio file. Audio URL, passing the URL as a source into this, passing this URL as a source into this audio here. So let's console.log that again. Let's see what it gives us. Let's use this. Yeah, can you see that we have this audio element with the source, right? Can you see now? I can even play it from here. I can say audio.play. Okay, so let's pick another file. Let's pick this. Let's open it. Yeah, we have to play in the background already. Yes. So automatically you see that we have the audio playing in the background, right? So let's refresh. Let me pick another one. I created. Let's pick this. Yeah, so ignore this error. Actually, you just ignore the error. Can you see we have the audio playing, right? So let's keep up. Now we have this. We've analyzed the file. Yes, we checked the file existed, and then we analyzed the file. Now we created the URL, right? So that we have an audio file that has the source of that URL. Then we have play button automatically. Yes. Okay, now very good. So delete this console.log and then we'll move on. Now for us to now create the visualization effect that appears on the screen. That is very, very simple. Okay, we've done everything. Now the next on the line is to get the audio context, right? Audio context const so we say audio context equal to, now there is a the property called audio context in the window function, okay, which actually contains everything you need for an audio. Audio context, yeah, this is what we have here. We have the audio context. Yeah, can you see now? So when I console.log that audio context, you're gonna see what happens. So everything actually happens still from this event listener. Remember, we're passing the function differently. So I'm going to say choose file. Let's go for this. I'm going to inspect, it's playing actually. Okay, my thing failed. Okay. Wait. So let's refresh. Let me do that again. Pick this and play. Oh, sorry. I meant to. So we are going to console.log the audio context. So for the audio context, automatically we have this display here. Can you see we have the audio context, the latency, the sync ID, the output latency. We have the audio worklet. So we have the destination. Okay, we'll talk about that later. We have the context of the file. Can you see the base latency, the destination, the listeners that you can apply with it. We have the channels. Okay, both the input and the output, the count, and everything that we need for the audio API automatically. So very fresh to keep that audio out. So now next on the line is, after consoling this, we don't need that now for now. So that the audio context actually needs okay, to be attached through a media element source. Okay, so we're going to say const audio audio source equals to, now this audio context that we have here. So we have the audio context dot, we're going to create a media create media stream source or media element source, okay, which will be the media element source for that audio, automatically. So after creating that, next on the line is to now analyze the file, right? We're going to create an analyzer. Now our analyzer can be created with this, that I said, this audio API can actually contain everything that we need for that audio, the visualization, the volume, the latency, everything that we need for that audio. Automatically I can say constant, oh no, let's not do that. I can say audio context dots. Now we're going to analyze, right? Create analyzer. So we're creating an analyzer. Okay, so let's put that in, let's store it somewhere. So we're going to say analyzer equal to audio context dot create analyzer. Now we are creating this analyzer to actually get our display, which are visualization on the screen. Okay, now after getting this analyzer, we're going to set what we call the fast Fourier transform, which is FFT. Okay, FFT actually is a Fourier transform based function in mathematics. We have what we call Fourier transform, which actually used for getting or used for analyzing audio signals automatically. So we're going to say analyzer dot FFT. Okay, FFT size equals to let's set it to 256 automatically. So now this fast Fourier transform is actually always in even values, okay. And then from this FFT size, we can also get what we call the frequency byte count, okay, which is always half of this FFT size. Okay, so I can say console.log, much to help you do that. Console.log analyzer dot frequency bit count. So let's see what that gives us. So I have this. I'm gonna pick this cool bit here. So it's playing automatically. Let me increase my volume. Oh, can you see we have 128 showing there? So I have this. Okay, can you see the value of the of the frequency being count, which is 128. Can you see always half of this FFT size as always an even number? Okay, FFT actually means fast Fourier transform. Fourier transform, you can make a research in mathematics. It's actually a function of like mathematics is a function in mathematics that actually deal with analyzing audio signals. Okay, let's move on. Okay, so now next on the list is going to be very different now. Now after getting this, after setting the FFT size, okay, we're going to now connect the analyzer to the audio source and also connect the destination of the audio context to the analyzer. So we're going to say audio source dot connect. Now connecting the analyzer itself, okay, and we're also connecting the connecting the audio context destination. So audio context you're connecting the audio context destination to the analyzer. So our analyzer dot connect audio context dot destination. I'm making this video soon to break down everything I did here, okay, because after this project I'm going to create the ones that actually you have to do a real music production on. As a music producer that I am, you have to do a real music production on, and so you have to add your EQ, equalizer, you're going to add your reverb. So you're talking about things like that. You're going to be talking about convolver in JavaScript, what we call convolver from these audio sources in JavaScript. So we're talking about that when we get there, when I start doing the project. We're adding compressor, adding so many effects that can create a live audio track. Okay, let's go on. This will actually be very helpful for audio engineers and producers like myself. Okay, so let's continue. So now for this, I have added imputed the analyzer to the audio source and also added the audio context destination to the analyzer. Let's console.log the audio context destination and see what that is so you can know better. Audio context dot destination. Okay, yeah, I have my specs here. Then console, let's see what that gives us. Let's refresh. Click on this, open the file. This is the audio. Can you see? So we're explaining everything that I'm explaining. So many things that we have here. Not everything because I don't know everything that is here. Still learning. Okay, let's close that and refresh. So now do away with this console.log. We don't need that for now. Next on the line is after getting this, after connecting the analyzer to the source and also the audio context definition to the analyzer, the next thing that we need to do now is to get our buffer length. They don't call buffer length. Buffer length is actually half size of this fast Fourier transform size that we have here, which is the frequency bin that we actually console.log the other time. So I'm going to say const the buffer size equals to analyzer dot frequency bin count that we actually got the other time, which is half of the fast Fourier transform size. Okay, note I said the Fourier transform size is always in even values. We have 120, we have 256, we have 64, and the rest. Okay, let's continue. So now what I need to do here next is now to get an array that actually stores the data array for the buffer length, and we are breaking it down into certain values. So we say new, we're going to use the unit 8 integer. Now use it array, okay, and pass this buffer size into it. Okay, let's console.log that and see what it is. Give us an array with different certain values. Let's console.log that data array. If you console.log this buffer size, I'm going to get 128 because we set it to 256. Half of 256 is 128. So let's try that and see what happens. I like the way I'm showing you guys everything step by step. Alright guys, so now let's console.log this data output. Let's see what that gives us. So we have console.log the data array that we have here. Going to see it's going to give us a long amount of data. For now it's going to be 000 all through. So let's pick the file that we want. We have this MP4 file. Yeah, can you see that it's playing already? This large amount of data from 0 to 99 and 100 to 177, the buffer to around 128. Okay, let's keep up guys. So come on. So let's close that, let's refresh to keep out that audio. Now next on the list is after creating this array, that's all we need. So we need to create an oscillation that will display in the canvas. Now for this oscillation we actually need this data array such that this data array will actually act as those value points that actually displays those 128 values that actually displays. So we're going to say create a function called draw oscillation. We're going to draw the oscillation now. Now for this oscillation we need a smooth transitioning. Okay, that means we are going to use what we call request animation frame. That's very cool. That's very popular in using in game development. Most times when you want to create a smooth animation in canvas, most especially. So we are going to request an animation frame. Now this request animation frame most times actually has to get the name of the file, the function that it actually covers. Okay, so that any animation that we put on that here is going to be smooth. Okay, now after doing that, we need to now get our canvas context that we have here. We get our canvas as a 2D. Okay, get our canvas context. Then we are going to actually fill it up with a style. So we're going to say fill style. Fill style of that should be, let's say, let's use a color. Let's use RGBA 90 250. Yeah, so we're going to do that. I'm going to say CTX, the canvas CTX also dot fill rect. So we're going to draw a rectangle round. So we're going to see that now on the screen. Okay, we're going to fill the rectangle right from the beginning, okay, to the canvas width and the canvas height. Yeah, so we're done that already. So let's choose a file now. Let me go for this jazz. Yeah, I think I played this jazz. Oh, it's not showing on the screen because we have this stuff. Let's avoid that. So let me go back to this. And use this, and then I have. Okay, it's not showing because we have wrong input there. So it's dot width. So let's try again. This it's not showing. Okay, let's move on. Probably we'll fix that later on as we move on. Alright, I think I know why it's not functioning yet, because we did not call this function draw solution actually. So we're gonna do this now. Let's see what happens. So let's make this blue and see what happens. Okay, we have canvas or client. No, that's wrong. Let's choose the file again. I think this one should work properly. Yeah, so we have this actually appearing. Now next, to apply those effects with the data array that we have here into this beast. Let's play the vibes, man. So yeah, I think I'm beginning to get excellent vibes from that. So what I'll do now is to create another function called draw bars. And I'm going to create this function inside this draw solution so that it will have this request animation frame, a smooth transitioning. Okay, we're going to show you that the reason why I'm using that. So we're going to say draw the bars. Okay, we're going to draw the bars, those bar chart that displays up and down. So now once you draw the bar, we're going to get the width of the bar. Okay, the bar actually needs a width. Okay, yeah, so we're going to call this bar width. Yeah, so this bar width is actually going to be equal to now the canvas actually has a width, right? That actually needs this buffer length, total number of buffer length. So we're going to say the canvas width. Those of you that are good at maths, the canvas dot width actually need to contain this total number of buffer length. So divided by the buffer size that we have. Okay, then we're going to multiply it by half, by 0.5. Yeah, so after getting that bar width, we're going to look through this buffer size. Okay, we can call it buffer length if you want, but I use buffer size. Now you're going to go, look through this buffer size to get individual bars that will display on the screen. Okay, so we're going to say for loop. If you're familiar with for loop, so we're going to start with 0. Let I equals 0. Then we're going to say I should be less than the buffer length size, buffer size. Okay, then arrow. Then we keep increasing the value of the I till we get to the value that's less than this buffer length. So we have to increase it. Yes. So now I have this showing here automatically. So what I need to do here now is very simple. So I'm going to say let the bar height that we got there. Now the bar height should actually be equal to the data array of each value that appears inside the data array. Okay. Now remember, then we had values of 0, 0, 0 all through, right? We can have values of 30, 60, just random numbers, right, inside that place. So we're going to say each of those values, each of those values that we get from the data array index, we're going to show that each of the value should have an height. Okay, that means if we have a value of height 30, the height there should be 30. If it's value of 20, you're looking through that data array, okay, so that we're getting the height. Each of those bars that were popping up on the screen actually have different heights. Okay, Okay, those are the height that we are going to get now from this data array automatically. Now for this, we are done with that. Now we're going to get the color that will display. Okay, it will display with, let's say we're going to use a light green. Let's use a lemon color. Okay, now we're going to say this canvas CTX also. The fill style should be this color that we had here. Okay, then after with the fill style, we're going to say this, we're going to create a rect automatically again. That will be this same stuff. So what we need to do now is to call this function drawbars. Let's see what that gives us. Let's sort that. Let me see what the problem is. Okay, I think we didn't pass the data array. Yeah. So let's try again. Yeah, automatically here we have this output, guys. Can you see? So we have this output, guys. Yeah. So I can also change this, the way it's displaying. You can use get time, byte time domain, which we use a bouncing effect. Waveform. Yeah, this is sinusoidal. Can you see that bounce, that hit? Bouncing there, yeah. In response to the flow. So please don't forget to like and subscribe. If you have any questions, please type in the comment section. Have a great day, guys. Enjoy. Don't forget to read this link. Bye bye long, guys.